Before you start this video, make sure that you've gone through step 1, step 2, and step 3 of how to install Eclipse in the JDK at home at mrbuca.net/java.html if you don't have Eclipse or the Turtle library already set up inside your program. Hello, welcome to Java lesson number 1. Today we're going to talk about variables and objects and a couple other things. And we're going to focus on using the Turtle Tome, which is on mrbuca.net in the program and web page. So, objects. If you think about objects, those are living things or non-living things that do things for us. So, a cup is a non-living object, and that does something. A car, a human, or in our case, a turtle. Objects are created by a class using the construction method found in the class. The turtle, in our first actual example in chapter 2, that we name Turtle, is an object, and that's an object of the turtle class. I do want you to notice something, that the capital T in turtle, that is an intentional use of the capitalization, because all classes, when we refer to them, will be referred to in the proper syntax, which would be starting with an uppercase letter. Objects are also sometimes referred to as an instance, so if you hear somebody or myself speak about an instance or an object, it's the same thing, they're synonymous. So a class is like the factory that creates all these objects. So again, for our example, the turtle class, which we didn't create, it came in this package that we downloaded. We didn't create it, but we can use that class and its constructor to create as many turtles as we'd like to. Now in our first example, we're only creating one turtle and we call it Turtle. The class defines the object and states what objects of that class can do through its methods. An example is that our turtle can move forward. We can also do some other things like set the pen color of the turtle. We can change its orientation. We can do several other things that we're going to learn about very shortly. A class, like I said before, always starts with an uppercase letter. So here's 3 examples of class names that I might create. Turtle with a capital T. Draw line, which is our very first one in chapter 2. Notice the capital D and the capital L. There is no space. A third example, perhaps 3 words, rectangle creating turtle. Notice the capital R, the capital C, and the capital T, and again, no space. Class names should be descriptive of the objects that it creates. So what I'm saying is, if we were to create a class whose purpose was to create turtle objects for us to manipulate, we shouldn't call it, we shouldn't call it public class ball, because it doesn't make any sense. But if we call it turtle, then the user or the programmer can expect that we would create turtle objects with it. Well, for each object or each class, you have to have variables. And we're going to discuss these 4 types of variables very briefly throughout this conversation. And like all of this stuff, we'll be talking about this and kind of coming back to it so that even if you don't get it the first time, as you listen to other lessons, these things will start to make more and more sense to you and you become more comfortable and more familiar with this terminology. There's instance variables. Again, remember that instance and object are the same thing. Class variables, local variables, and parameters. Instance variables describe the current states of the fields or the variables of any given object or instance. So for example, the turtle that we create, known as Turtle, it has an orientation. Its field or one of its variables is orientation. And what that does is it stores the current state of which way that turtle is facing. And I guess if we were to talk about us as humans and we were a class in Java, you'd have several variables or fields such as location, age, hair color, and many other. Now, those all store current information about you as an object of the human class. I also want to note that some fields can't be changed. Even though your age does iterate 1 year at a time, your hair color can change invariably. Some can't. For example, who your parents are. You can't change that. What ethnicity you are. That's something that you have no power to change either. So some variables or fields are static in that they can't change. Local variables are created within methods. Now, most of our methods, and we'll talk about those in a couple minutes, most of our methods have some sort of variables in them, all right? So in this particular case, knocked is a variable that we create inside this method, and we actually assign it to, which we'll talk about soon. But the thing is that this variable, knocked, can only be accessed within that method. No other method outside can access this variable anywhere within the class, and no other class can access it as well. So a parameter is another type of variable, and a parameter also is affiliated with a method. You'll notice that in this particular case, the method signature, or the method header here, public void knock, takes in a parameter integer knock. So this takes in a number. Now, if you were part of a secret society and you had to have or you were part of 2 or 3 of them, they all have their own knock systems on the door. So you know that your Tuesday night secret society requires 4 knocks. Well, that's what a parameter is for. A parameter says, okay, specifically what would you like me to do? And in this case, we'd say we want you to knock 4 times. And then our Wednesday night one has a 6 knock system. So again, we're using the same sort of action or method, we're knocking on a door, but we're doing it slightly differently by being specific with a parameter how many times. It sort of goes back to that one old saying, you know, when I tell you to jump, you say how high. So it's being very clear. It's almost like an adjective. It's being descriptive as to exactly what do you want me to do. I know you want me to knock, but how many times? I know you want me to jump, but exactly how high? And that's kind of what a parameter does. It really details the action. So a summary for variables here. Proper syntax, all variables should always start with a lowercase letter. So our classes start with an uppercase letter, but our variables start with a lowercase letter. So some examples might be speed or turtle speed. And I want you to notice that turtle speed has no space in between them, and that the second letter does start with a capital. So lowercase t, turtle, and then uppercase speed. And then our third example, turtle pen color. Again, notice it starts off with a lowercase. There's no space between turtle and pen. Pen starts with a capital letter, and color starts with a capital letter. Their names should also be descriptive as to the purpose of the variable. So I wouldn't use a weird variable name like J for my age, because a programmer or a regular person wouldn't know what that variable does, wouldn't even have a clue. But if we said, you know, int age, then almost anybody, whether they program or not, would think, well, if that stores something, it probably stores the age of whatever this is. So now we go on to statements. And statements is something that you'll learn more and more about as you go on. But it's a part of a code that tells a computer or a device what to do. Usually, a statement ends with a semicolon, and that's usually. Statements can include if statements, while statements, variable declarations, and many other types. They're really ubiquitous in many codes, and it's hard at first to know what a statement is. But again, as we progress through some of these conversations and as you get more experience, you'll be able to very easily identify statements. So if we look at this figure in Chapter 2, I've highlighted in red some of the statements. Everything else outside is not a statement. For example, import turtles, well, I guess it is a statement actually, it's an import statement. But public class drawline extends turtle program, that's a class header. Public void run, that's a method header. Inside the red, turtle URL. That line of code there is declaring a variable of a turtle type, and we're going to name it URL. So notice how we had to capital T, the turtle, and then lowercase URL, because the variable name is URL, but it is a turtle object or a turtle instance. And then we assign that variable URL a value. And what we're really doing here is we're running the constructor for the class turtle, which is helping us create a new turtle at the coordinates x50, y100. Notice how it ends with a semicolon. And then we have another statement. We're telling Turtle to move forward using its forward method, and we're saying 100 pixels, and then we end the statement with a semicolon. And then finally, Turtle.hide, semicolon. We're telling Turtle to hide. So that kind of brings us into the conversation about method and instance method. A method is an action that can be taken by a program. Usually when we create methods, it's because this action is common. It recurs a lot. So move, draw. In a video game, it would be fire or jump. Sometimes programmers refer to these as functions. So functions and methods or instance methods are relatively synonymous. So in this particular case, if we look at this code, some of the instance methods we see, because we know that instance and object are the same thing, and we know that we created a turtle object named Turtle, some of the instance methods here would be forward 100 or hide. So we are allowed to work on this instance. We're able to tell it to do that action. So we're going to look at the API really quickly, and we're going to see how we can read the API and use it in our code. So I want to take you to the Chapter 2 page here, and I want you to see on the left, you can see that there's a Turtle API right here. If you click on the Turtle API, this is very much like what you might see in a professional context of programming. You would see this if you went to Oracle's site and you looked at the Java API, although the Java API is much more complex than what we see here. But again, this is a great introductory piece. So I'm looking at the package turtles, which is lowercase t, and I'm looking at what classes are in this package. Thankfully, there's only two. There's a turtle class and there's a turtle program class. Well, I want to learn a little bit what I can do to my turtle instances, so I need to look at the turtle class. Now when I look here, I see some information. Constructor summary. It tells me how to construct one, which if we look back at any of our code, we can see Turtle equals new turtle 5100. If I look back at the API, sure enough it says turtle XX Y. So where does it start? All right. And then if I look at method summary, I can see draw to, face, forward, get orientation, get pen color. So I can see all these things that I can do, methods or actions that I can do with my turtle. So one thing I'm going to take a look at is the left. All right. So I'm going to see left double angle turns this turtle angle degrees counterclockwise. All right. So what I'd like to do is before my turtle hides, I think I'm going to say Turtle dot left, and you can see I'm starting to get some code hinting here. I'm just going to click on that, show you how to use that while I'm at this, and then angle. I'll say 90. All right, so a 90-degree angle. And then I'm going to have Turtle, I'm going to run another instance. I'm going to move them forward another 100. So now I'm going to see what happens with my code. It used to just draw a line, but now that I've run these new instances using the API, I'm going to see what it does. So I will run the code. Okay, so my Turtle moved forward 100 pixels, and then he turned left 90 degrees, and then he went forward 100 more pixels, and then he hid. So that ends this conversation. Hopefully you have a better understanding of objects, classes, constructor methods, variables, and instance methods. Don't worry, more practice will make it even better.